You're looking at a line segment. The endpoints are labeled A and B, so we can call this line segment segment AB. Now we've placed a point in the middle that appears to have divided the segment into two equal parts. And that brings us to a definition. Midpoint. A midpoint of a segment divides the segment into two congruent segments. In this case, of course, the midpoint is point M. And what this definition tells us is that if M is given as the midpoint of segment AB, then we can conclude that segment AM is congruent to segment MB. And because the definition is reversible, if we're told that segment AM is congruent to segment MB, then we can conclude that M is the midpoint of segment AB. A midpoint bisects a segment. A segment, ray, or line containing the midpoint of another segment bisects the other segment. All segments have midpoints, and a segment has just one midpoint. Rays and lines do not have midpoints because, of course, they go on infinitely, so there's no way to divide them into two congruent pieces. Here's an example. We have our original segment AB and our midpoint M, and line LM passes through M, so we say that line LM bisects segment AB. Now we have a ray that starts at point M and goes off into the upper left side of the frame. And since ray MP contains the midpoint, we say that ray MP bisects segment AB. And here's one more example. We've added a segment that passes through the midpoint, so we say that segment ST bisects segment AB. And now, for clarity, we removed the line, the ray, and the other segment, and we have a new line, line DM, and you'll notice the little symbol, and that's the symbol for right angle. Perhaps you've seen that symbol before. So this is a special case. Not only does the line DM bisect segment AB, we say that line DM is a perpendicular bisector of segment AB. And now we have that segment DF is a perpendicular bisector of AB, and if M is the midpoint of both segments, then the segments are perpendicular bisectors of each other. Now you have the same segment, and it looks like this segment has been divided into three congruent segments by points G and H. Another definition: trisection points. Trisection points are 2 points that divide a segment into two congruent segments. So if we're given that G and H are the trisection points, we can conclude that segment AG is congruent to GH, which is also congruent to HB. And then, because the definition is reversible, if we're given that those three segments are congruent, then we're allowed to conclude that G and H are trisection points of segment AB. And now let's look at angles. Here's angle ABC. And we add a new ray, ray BD, shown in red for clarity. And that ray seems to be right down the middle of the angle, and of course it is. This ray BD divides the angle into two congruent angles, and that gives us yet another definition, angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. And since we're given that ray BD bisects ABC, we can conclude that angle ABD is congruent to angle DBC. And because the definition is reversible, if we're given that those two angles are congruent, we're allowed to conclude that ray BD is a bisector of angle ABC. And now you can see we've added two rays that appear to divide the angle into three equal parts. And yet another definition, angle trisectors. Two rays that divide an angle into three congruent angles are angle trisectors. So if we're given that BE and BR trisect angle ABC, we can conclude that angle ABE is congruent to angle EBF, which is congruent to angle FBC. And because the definition is reversible, if we're given that the three angles are congruent, we can conclude that ray BE and BR trisect the original angle ABC. In this lesson, we had four definitions: midpoint, trisection points, angle bisector, and angle trisectors.